Hi everyone, welcome to lesson 3.1 where we're going to talk about exponent laws. So let's take a look at the first one where we're going to talk about multiplication of exponents. So when we multiply powers with the same base, we're going to keep the base the same and we're going to add the exponents. So let's fill that in there. So the algebraic example is if I have a to the power of m times a to the power of n, what I do is I keep the same base, a, and I add the exponents, m plus n. So if I look at a numerical example, and I have 5 raised to the power of 4 times 5 raised to the power of 2, again, I keep the same base, which is 5, and I add the exponents. So here, this is 4 plus 2. So simplifying that, I'll have 5 to the power of 6. So I'm just using this to take a look at the exponent laws, but if you want to go ahead and evaluate that on a calculator, you go ahead. So let's take a look at division. So the law for division is when we're dividing powers with the same base, keep the base the same, and here we're going to subtract the exponents. Algebraically, if we have a to the power of m and I divide it by a to the power of n, then I keep the same base and I subtract the exponents. Remember, when we subtract and when we divide, the order matters. So here, since m is in the numerator and n is in the denominator, when I subtract, I have to take m minus n. All right, so let's take a look at a numerical example. And here I have 4 to the power of 5, and then I have 4 to the power of negative 3. So let's be careful with that negative sign. But we keep the same base, and then we take the exponent from the numerator. Here, this is 5, and I subtract the exponent from the denominator. And in this case, that's negative 3. So what we're really doing is we are minusing negative 3, which then becomes a positive. So this one simplifies to 4 to the power of 8. Again, go ahead and evaluate on a calculator if you would like. Our next exponent law is called power of a power. So when we're taking the power of a power, we're going to keep the base the same, and now we are going to multiply. So if we take a look at the example, I have a to the power of m, and I'm raising all of that to the power of n. So I keep the base the same, and in this case, I multiply those exponents. Numerically, if I have 3 to the power of 4, and then I raise it all again to the power of 4, this is going to be 3 to the power of 4 times 4. And here I'll get 3 to the power of 16. Okay, so let's move on. The next one we see is negative exponents. And for negative exponents, we take the reciprocal of the base and then make the exponent positive. So here we are with our algebraic example. If I have a to the power of negative n, then I take the reciprocal of a, which is 1 over a, and then I change the exponent to become positive. So it went from negative n to positive n. We'll take a look at that again with our numerical example. So I have 1/2 to the power of a negative exponent, negative 3. So the first thing is I take the reciprocal of 1/2, which is 2, and then I just change the exponent to be positive. So this is 2 to the power of 3. And the last one that we'll take a look at is called the zero exponent. And basically, that's just a law that any power with an exponent of 0 always equals 1. So anytime you raise anything to the power of 0, it's always going to equal 1. So algebraically, we have here a to the power of 0, and that equals 1. And so with my numerical example, I just wanted, again, to reiterate anything to the power of 0 is always 1. So even if we have 35 to the power of 4, because we're raising all that to the power of 0, this is still equal to 1. So let's take a look at some examples. And when we simplify expressions, we want to make sure that all of our exponents are positive. Our simplified answers should all be positive exponents. So if I have 3 to the power of 3 times 3 to the power of 5, again, we have the same base. I'm going to keep the base the same. And the multiplication law says I have to add these exponents, so 3 plus 5. This simplifies to 3 to the power of 8. And then what we do here is we would evaluate this on a calculator, and this comes out to 6,561. Taking a look at example B, we have 4 to the power of 5 divided by 4 to the power of a negative 2. So what we'll do here is we'll keep the exponents in the right order. So it's going to be the exponent from the numerator minus the exponent in the denominator. So I keep the base the same, which is 4, and I'll have 5 minus, and in this case, this is negative 2. So we're minusing a negative number, which again turns it positive. So we have 4 to the power of 5 plus 2. So that's 4 to the power of 7. And if you want to go ahead and evaluate that, it's going to be 16,384. Okay, let's go to the second page and we'll continue with our examples. Here now we're starting to take a look at examples that have variables in them. So this is x to the power of 3 times x to the power of 5 times x to the power of negative 2. They all have the same base, so we can keep the base the same, which is going to be x. Now, the multiplication law says that I have to add the exponents. So this is going to be x to the power of 3 plus 5 plus a negative 2. So if I simplify that, I'll have x to the power of 3 plus 5 is 8, and then minus 2, this is 6. Okay, and again, this one ends up with an exponent that is positive. It's positive 6, but we want to make sure that any of our answers have all positive exponents. All right, let's take a look at D. So we have n to the power of 5, and we're going to divide it by n to the power of negative 3. We have to watch our signs, and we have to watch the order of the power. So we're going to keep the base the same, and we're going to take the power of the numerator, and we're going to subtract the power of the denominator, which is negative 3. So again, we're subtracting a negative. So here this simplifies to n plus 5 plus 3, and this is going to be n to the power of 8. So I go back to some numerical answers, and really you can start in the brackets. You could evaluate 2 to the power of 3 and then raise it to the power of 2, but let's use our exponent laws. So we're taking the power of a power here. So this would be 2 to the power of 3 times 2. So this works out to 2 to the power of 6. And then if you want to go ahead and just plug that part into a calculator, you should get 64. We'll look at F, the example here. Again, power of a power, but we have negative exponents, and we multiply them when we're taking power of a power. So this is going to be r to the power of negative 2 times negative 3. So that simplifies to r to the power of 6. Good. Take a look at G. Now we're going to start combining variables, and we're going to treat them all the same. So in your mind, you could keep all the A's together, or you can rewrite them together and then keep all the B's together. So just to show you what I'm talking about there, I'm going to remove the brackets, and I'll have a to the power of 2 times a times b to the power of 2. Okay, so I took these two variables out, put them side by side, and then I took the other variables out and I put them side by side. Remember, the power laws, or the exponent laws, only apply to things that have the same base. So we have to treat the first two variables, they have the same base a, their multiplication. So we're going to add their exponents. So this is 2 plus 1. So we don't see a number here, right? And when we just take a variable and it has no power on the top, we assume it's 1. And then we're going to multiply that by b. Again, this missing number is really 1. And we're going to add 2. So when I simplify this, I get a to the power of 3 times b to the power of 3. And this is as far as we can go, because a and b, we don't have the same base there, so there's nothing we can do with those exponents. Okay, let's take a look at h. This is m times n to the power of 4, all raised to the power of 3. And if I take a look inside the bracket, I have two variables, m and n. So they're not the same base. I can't do anything there. And so I'm looking at power of a power. And here what we want to consider is this is almost like distributing, like the distributive property. But we're going to take this power on the outside and we're going to distribute it to the first and the second variable. So that's going to look like m to the power of 3, and then n to the power of 4 times 3. So m to the power of 3, and then we'll just simplify the exponent on n to be 12. The next one, we have the division law, and we also have power of a power. So typically, if we take a look at bedmas, let's rewrite that for you, bedmas. We should look at doing the brackets first. So we could simplify that first. And here we'll get x to the power of 4 minus 2, but that is still raised to the power of negative 2. So this will simplify to x to the power of 2 raised to the power of negative 2. And then finally, for my power of power, I'll have x to the power of 2 times negative 2. And I'm going to need a little more space here. But I'll have x to the power of 4, negative 4. And remember at the beginning when we started these examples, we said that all of our answers have to be with positive exponents. So how do I write x to the power of negative 4 as a positive exponent? Well, that's the negative exponent property. So I have to take the reciprocal of the base. So the base is x, so I have to take the reciprocal of the base, and then I just change the power to positive. So it's 1 over x to the power of 4. All right, let's take a look at the other one. Again, starting to look complicated, but we just want to make sure that we simplify everything one law at a time, and we'll be okay. So we have a to the power of 4 divided by a to the power of 6 times b to the power of 6, and we raise all of that to the power of 2, times b to the power of 5 divided by a to the power of 2, all raised to the power of negative 1. So if we take a look at our brackets first, the only thing that we can simplify here in the brackets is this a to the power of 4 and this a to the power of 6. So we have the same base, we'll keep that together, and that's going to be a to the power of 4 minus 6. Now that's the only thing that I can simplify there. The b is still raised to the power of 6. That comes over from the bottom. and then all of this is still raised to the power of 2. Times, we can do this simultaneously. We have a -1, and since we have a negative exponent, we can flip that and get the reciprocal. So I can switch this to a to the power of 2 over b to the power of 5, and now that would be raised to the power of +1. But we don't really write the power of 1. So let's go over here and see if I can make use of all this space. So this is going to be a to the power of -2 divided by b to the power of 6. We still haven't done power of a power, and that has a 2 on the outside. And then we did simplify the second bracket already, so there's nothing further to do there at this point. But now we have this -2. And so to make it positive, I can take the reciprocal of a. Remember, we're just going to take the reciprocal of a and not b because it's the exponent on a that is negative. So that'll make it 1 over a squared. We make that exponent positive. B to the to the exponent 6 is already down there. And we have to raise all that to the power of 2, and we still have a squared over b to the 5, because we're still waiting to simplify that. Now we have power of a power, and we have to make sure we sort of distribute this 2. We have to raise 1 to the power of 2. We have to raise a squared to the power of 2. And we have to raise b to the power of 6 to the power of 2. So let's take our time. 1 to the power of 2 is just 1. A to the power of 2, again to the power of 2, is going to be a to the power of 4. So let me change colors here. I took this squared on the a and multiplied it by 2. And then I have to take the exponent on b, which is 6, and also multiply it by 2. So I will have b to the power of 12 times a squared over b to the 5. So further simplifying this, we'll have, I'll write it all out together. So 1 times a squared is just going to give me a squared all over a to the power of 4. And then we have b to the power of 12 times b to the power of 5. So our exponent law says I have to add those exponents. So this is going to be b to the power of 17. Stick with it. This one's kind of long, but we have a squared over a to the 4. So we can just simplify this one. We can reduce 2 over 4. So I'll have 1 over a to the power of 2. I reduced this exponent with this exponent. That left me with 1 over a squared. And then b to the power of 17 cannot be simplified with anything else. So there's our final. 1 over a squared times b to the power of 17. All right. Now we're going to go forward. We're going to take a look at some numerical examples. With these negative exponents, we end up with some fractions. So we're going to have to be comfortable working with fractions. So let's start to evaluate. Now this here is addition. We don't have any exponent laws for addition, so we need to be careful with this. We have to evaluate 3 to the power of 4, and that's going to give me 81. And we're going to add it to, now how do I rewrite this 3 to the power of -1? I take the reciprocal. So that ends up becoming 1 over 3. So now before I can add fractions, you always have to have the common denominator. So we'll change this 81 to a fraction that has a denominator of 3, and that results in 243 over 3 plus 1 over 3. And simplifying that, I get 244 over 3. And if you check on that, this fraction can't be reduced any further, so we can leave it just as it is. Let's take a look at B. Here we have a 0 exponent, and we know that anything to the power of 0 is 1. Then we have a negative exponent, and to make that positive, we have to take the reciprocal. So this is going to be minus 1 over 2, and we make that exponent positive. So if I simplify that fraction, I'm going to have 1 minus 1 over 4. And again, we need common denominator before I can subtract fractions. So we'll change that 1 into 4 over 4. Then we could subtract our 1 over 4. And our final is 3 over 4. Again, can't reduce this fraction anymore. And so that's our final. A couple more examples. So C, we have 9 plus 9 to the power of negative 2, and then plus 9 to the power of 0. So nothing to simplify with the first 9. There's no special exponents there. But we do have a negative exponent right here. And so to make that positive, I take the reciprocal of 9, which is going to be 1 over 9, and I make that power positive 2. And then 9 to the power of 0 is going to be 1. So let's tidy this up a little bit again. 9 plus 1 over 9 squared is 1 over 81 plus 1. Again, we have some additions with a fraction, and we have to have a common denominator. So let's go ahead and create the other two terms, 9 and 1, create them into fractions with a denominator of 81. So 9 becomes 729 over 81 plus 1 over 81 plus, we change that 1 into 81 over 81. When we're adding fractions, we add straight across the top, and we keep the denominator the same. So this is going to be 811 over 81. You can try, but I don't think that this fraction can be reduced anymore, and so we can leave it just like that. Okay, so here we have a negative number raised to a negative exponent. Definitely want to make sure we take a look at how we deal with these negative signs. So what I want you to note is that this negative 3, that negative sign is sort of attached to the 3 in the bracket. So when I raise it to the power of negative 2, it means I'm raising the entire bracket to the power of 2. Sorry, negative 2. But then, yes, that brings up that our exponent is negative. And so to make it positive, I have to take the reciprocal of negative 3. And that's going to be 1 over negative 3. And then we're going to raise that to the power of 2. Because we just changed the exponent to become negative, we took the reciprocal. We're going to multiply that by 3 to the power of 3 is 27. And then minus 3 to the power of 4, which is 81. Let's simplify this. So 1 to the power of 2 is 1. And negative 3 to the power of 2 is really negative 3 times negative 3. So it becomes positive 9. And we're going to multiply that by 27 minus 81 is negative 54. We don't need a common denominator. We are not adding or subtracting at this point. We're just multiplying straight across. And so with that negative sign, I get negative 54 divided by 9 is 6. All right, 2 more examples. Negative 5 raised to the power of 2. That negative is inside the bracket with 5, so that means I'm technically squaring that negative as well. So it's really -5 times -5, which would make a positive 25. And then subtract. We have -5 to the power of -1. So we'll take the reciprocal of -5, and then really that just changes it to +1. And we don't really have to do anything if we have an exponent of 1. So we really have 25 minus, we have minus a negative fraction, so that really changes it to plus 1/5. So we have to change, now we're adding fractions again. We have to go and change this 25, to have a base of 5. And when we do the multiplication, this ends up with 125/5 plus 1/5. And the final answer here is 126/5. And our last example, 4 to the power of -2. Right here, we have then plus 4 to the power of 3 times 4 to the power of -1. So let's deal with our negative exponents, and we'll just change all the reciprocals, or we'll find all the reciprocals. So 4 to the power of -2 is the same as 1/4 to the power of 2. Plus 4 to the power of 3, well, there's nothing really to simplify there other than to evaluate that, so that is 64. But we're going to multiply that by 4 to the power of -1, which again, to make that -1 a positive exponent, we take the reciprocal of 4, which is 1/4. And we simplify. So we have 1/4 squared. That really gives us 1/16. Plus, we have 64 times 1, then divided by 4. This ends up being 16. And then we end up having to add fractions. So I need to make this 16 right here into a fraction that has the base of 16. And so I end up having to have 256. That's 16 times 16. And the final answer here is 257/16. All right, good. So that covers all of our examples for this section. Go ahead and try the worksheet, and let me know if you have any questions. All right, thanks.